All right, let's get right into it. Today we're diving deep into something that's, I think, always on people's minds. It's alien life.
Exciting.
But here's the twist. We're not just looking for them. Are they out there?
Right.
We're going deeper. We're asking what makes it even possible for life to exist at all.
Okay, I liked it.
And a listener sent in this really fascinating article titled Reimagining the Drake Equation. Scientists uncover new clues about alien life. And it really got us thinking about the universe in a whole new way. So what stood out to you when you read this?
You know what really grabbed me was the way it kind of flips the script on how we think about finding life.
Yeah.
You see that classic Drake equation. It focuses on calculating the probability of, intelligent life that we could find within our galaxy. But this new model,
Yeah.
it goes way beyond that.
Yeah.
It examines the fundamental conditions for life itself, even across hypothetical universes. It's wild.
I know. And that's where things get really mind-bending, because this article goes into dark energy, that mysterious force that makes up the majority of the universe. And for a long time, it was considered just empty space.
Right.
But now this model's saying, wait a minute, dark energy plays a critical role in shaping the universe and influencing where life might even emerge.
Exactly. And it all comes down to how dark energy impacts the expansion rate of the universe. It's like setting the stage for, life's grand play. And here's the kicker. The article even suggests that our universe, with the amount of dark energy we have, might not be the most life-friendly configuration possible.
Hold on. More dark energy equals more life. That sounds counterintuitive. I always thought dark energy was this force pushing everything apart, making things less dense. Wouldn't that make it harder for stars and planets to form?
You would think so, right? But remember, dark energy also affects how quickly the universe expands. So in some hypothetical universes, a higher density of dark energy could actually lead to more stars forming overall.
Okay, I need an example, something concrete to help me visualize this.
Of course. The article highlights this difference in star formation rates.
Yeah.
So imagine a universe with just the perfect conditions for making stars. This model predicts that such a universe would convert about 27% of its ordinary matter into stars.
Okay.
Now compare that to our own universe, which only converts about 23%.
Wow, that's a huge difference.
Exactly.
So even though it's strange, a higher dark energy density could mean a universe just sparkling with way more stars than our own night sky.
Precisely.
Okay.
And a greater abundance of stars leads to a greater number of planets.
Right.
And therefore more opportunities for life to take root.
My mind is officially blown.
Right.
But here's the question. If our universe isn't optimized for life, why are we even here? What does this tell us about our place in the grand scheme of things?
That is the million-dollar question, isn't it? It really challenges our assumptions about the fine-tuning of the universe, right? Maybe we aren't in the most life-friendly situation possible.
Yeah.
And yet here we are.
Exactly. And it makes you think, how unique or common is life actually out there? If our universe isn't, top tier for life.
Yeah. It's like we've been thinking our universe is the ultimate penthouse, perfectly designed for life.
Yeah.
But maybe it's more like a cozy studio apartment.
I like that analogy.
Yeah.
Yeah. Still functional.
Still functional.
But maybe not the, ideal situation.
Right, exactly. And that leads to another cool concept the article talks about, the multiverse.
Okay, yes.
Yeah.
The multiverse, multiple universes, each with its own, physical laws and properties. We're not just comparing neighborhoods here. We're talking about entirely different cities with different rules altogether.
Exactly. And it allows scientists to compare our universe to these hypothetical ones with varying dark energy densities.
Okay.
Like the article mentions a model where there's 5 times the dark energy density of our own universe.
5 times. What would a universe like that even look like? Would it be just this chaotic mess of rapidly expanding space? Or could something else, something surprising emerge?
Well, according to the model, this hypothetical universe with 5 times the dark energy density could still form stars, although at a slower rate. It wouldn't necessarily be a chaotic void. What's fascinating is that even with these drastically different conditions, the model suggests there's still potential for structure formation and potentially for life.
So even in universes that seem, wildly different from our own, there's still a chance for something amazing to happen.
Yeah.
That's humbling and exciting.
It really is.
Yeah.
And that brings us back to that visual from the article.
Yeah.
The one showing the different star densities in these hypothetical universes. It just shows you how much dark energy can influence things.
Yeah, I'm looking at it now and it's striking. In some of these universes, the night sky would be ablaze with stars, so dense you could almost reach out and touch them.
Yeah, it really puts things in perspective.
It does, and it connects back to that classic Drake equation.
Absolutely. The equation tries to estimate the number of detectable civilizations in our galaxy, right? But this research really highlights the importance of understanding the underlying physics, the cosmic forces that shape the very parameters of the equation.
It's like we've been so focused on counting the trees that we've forgotten to look at the forest.
Yeah.
We need to understand the whole ecosystem, the fundamental forces at play, to really grasp the potential for life out there.
Precisely. And by exploring the role of dark energy in shaping the universe, we gain a deeper appreciation for how we got here, the conditions that led to our own existence.
But here's what I keep thinking about. If other universes could be teeming with stars and planets, does that mean they could be teeming with life as well? And if so, what would that life look like? Would it even be similar to us? Or something completely different?
Those are the questions that keep scientists up at night.
I bet.
We can speculate, of course, but until we have more concrete evidence, it's still a mystery.
Okay. So while we ponder the possibilities of life in those other universes, let's bring it back down to Earth for a minute. What are the practical implications of this new model? Does it change how we search for alien life here in our own galaxy?
It definitely provides a new lens through which to view our search for extraterrestrial intelligence. It encourages us to think beyond just looking for signals or habitable planets.
Okay.
Instead, we need to consider the underlying astrophysical processes, the cosmic environment where those planets form.
So instead of just scanning the skies for radio waves, we should also be studying dark energy and its influence on star formation. It's like we need to become cosmic detectives,
Exactly.
piecing together the clues that led to life's emergence.
It's a shift from a purely observational approach to a more holistic understanding of the universe and our place in it.
This has been an incredible deep dive. My brain is expanding to accommodate all these new ideas. But before we wrap up, I want to leave our listener with something to ponder. If our universe isn't the most life-friendly, what does that say about the potential for life in those other potentially more optimal universes? Could there be civilizations out there far more advanced than our own, shaped by a cosmic environment we can only begin to imagine?
Yeah, it's a really tantalizing thought, right? Like if these hypothetical universes do exist with these, more favorable conditions, what would life even look like there? Would it even be carbon-based like us?
Oh.
Would it evolve in ways we can't even comprehend?
It really is mind-boggling. It makes you wonder, are there other intelligent beings out there looking back at us, marveling at how life even managed to, arise in our seemingly, less than ideal universe?
Right, like maybe they see us as the ultimate underdogs.
Yeah.
Thriving against the odds. Maybe they even admire our resilience.
Or maybe they're just baffled by our reality TV shows.
Now there's a thought.
It really puts things into perspective.
It does.
So where can our listeners go to learn more about all this? I know I'm definitely adding this to my reading list.
The article you shared actually cites the original study, and it was published in the monthly notices of the Royal Astronomical Society.
Yeah.
That would be a great place to start for those who, want to dive into all those technical details.
Perfect. And for those of you who are like me and are still, pondering the big questions, I'll leave you with this. The universe is full of mysteries, and every new discovery opens up a world of possibilities. So keep exploring, keep questioning, and never stop looking up at the stars. Who knows what incredible wonders are waiting to be uncovered?
Well said. And maybe someday we'll find the answers to those questions that seem so elusive right now.
Until then, we'll keep diving deep into the mysteries of the universe, one article at a time. Thanks for joining us on this incredible journey.